So here we have a couple of cycles of the cosine function. If I want to find the inverse cosine function, we need to make sure that this function is 1 to 1. So let's make sure that it is 1 to 1 by checking, let's go with 0. So 0 gives me an output of 1. So now I'm going to look and see, is there any other place that gives me an output of 1? 2 pi over also gives us 1. So while this is a function, it is not a 1-to-1 function because the output of 1 gives us back 2 different x's. So this is not 1-to-1. Another way to see that is the horizontal line test. So let me take a horizontal line through those 2 points that we just discussed, and you'll see that it does not pass the horizontal line test because it crosses more than once. Okay, so this does not pass the horizontal line test. Still lead to the conclusion that this is not 1-to-1, and so because it's not 1-to-1, it does not have an inverse. So what we're going to have to do is restrict the domain, and where we've decided to do this as a mathematical community is starting from that 0 and then going until pi. So from 0 to pi, this will in fact pass the horizontal line test, which means that it has an inverse. So that means we're going to have to restrict the domain. Again, you could do this in almost really any spot on the graph, but as a mathematical community, this is what we've decided on. So this is what we all have to agree on. So restricting the domain between 0 and pi. So let's look at the domain and the range of cosine and its inverse. So if I call the cosine function f, so f of x equals cosine of x, then the inverse will be the inverse cosine. This -1 is not an exponent. It does not mean reciprocal of cosine. This means the inverse. So to relieve that confusion, some people call this the arc cosine of x. They mean the same thing. Okay, so in order to have an inverse, we're going to restrict cosine between 0 and pi. So that's our new domain. And then the range of cosine is still the regular range, which is from -1 to 1. Because we have an inverse, domain and range are going to flip-flop, so the range of f becomes the domain of the inverse. Okay, so the inputs are between -1 and 1, and then the outputs are going to be between 0 and pi. In other words, the outputs are going to be an angle. Okay, so that's really the best way to think about this, is that the inverse of f, in other words, the inverse cosine, is just an angle. Be really careful where you call that, though. This is an angle whose cosine is x, as long as that angle is between 0 and pi. So if we were to look at this on a unit circle, between 0 and pi. So we're looking at the top half of the unit circle only. So let's do a couple examples, finding what the inverse cosine is going to be, again, only in the top half of the unit circle. So let's say I have the inverse cosine of 1/2. Again, this is just an angle, so I'm going to call it an angle. Call this theta. So this is the angle whose cosine is 1/2. Looking only on the top half of the unit circle, because 1/2 is positive, it's going to be in the first quadrant. So the angle whose x-coordinate is 1/2 is at the point 1/2 square root of 3 over 2, which is pi over 3. Okay, let's say I have the inverse cosine of negative square root of 2 over 2. So again, this is an angle. We'll call it theta, looking only in the top half of the unit circle. So I'm looking for the angle whose cosine is negative, so that means we're going to be in the second quadrant. X-coordinate, that takes place when we have negative square root of 2 over 2, comma square root of 2 over 2. And that angle, treated between 0 and pi, is 3 pi over 4. Okay, a couple more. Let's say the inverse cosine of -1. again, is an angle, somewhere between 0 and pi. So I'm looking for where the x-coordinate, because it's cosine, is -1. Okay, so that's on the far left of the unit circle at -1, 0, which is pi. One more, let's say the inverse cosine of pi. So again, this is an angle, somewhere between 0 and pi. So I'm looking for the angle whose x-coordinate is pi, in other words, it's about 3.14, but we can only go as low as -1 and as high as 1. This is way too large. This does not exist. Again, because the range of cosine is -1 to 1, the domain of the inverse is also -1 to 1. Pi is too large.